Hello everyone, in this class, our main study is the welding method of the horizontal fixed wall position welding of the plug-in tube sheet. Through this lesson, the main things we need to know are: master the operation essentials of this welding position, can formulate welding plans, can select welding parameters, can weld qualified workpieces according to welding safety, cleanliness, environment, and welding process requirements, can do appearance self-inspect of workpiece according to standard. This is a construction drawing of the project. From the figure, we can see that this is a tube board compilation project. The compilation is a plug-in type. The outer diameter of the tube is 76 mm. The wall thickness is 10 mm, and the length is 100 mm. The bottom plate is a square plate with a length of 100 mm, a width of 100 mm, and a thickness of 12 mm. In the center of the bottom plate, a through hole with a diameter of 76 mm is machined according to the outer diameter of the pipe. According to the thickness of the test piece, the size of a welding leg is determined to be 8 mm, and 2 layers need to be welded, the bottom layer and the cover layer. A plug-in tube sheet weld is a special form of fillet joint that is relatively easy to master because it does not require back forming. However, in the wall position welding process, after the tube sheet is fixed horizontally, there will be a conversion from evaluation angle welding to vertical angle welding, and then to flat angle welding, which adds a certain degree of difficulty to our practice. We learn the specific welding operation method and process of the project through pre-welding preparation, assembly, base, cover, and inspection. Before the welding operation, we must do the following pre-welding preparations. 1. Safety inspection. Labor protection supplies must be properly worn and intact. Clean up the workplace, and no inflammable and explosive materials are allowed. 2. Welding machine preparation. Check whether the welding machine cable, welding handle wire, and welding tongues are connected well, and carry out debugging. 3. Preparation of auxiliary tools. Prepare grinding wheel grinder, straight grinder, snag hammer, chisel, file, wire brush, steel ruler, and a wheel inspection ruler. 4. Preparation of the test piece. Check the size of the test piece according to the drawing and use tools to remove the oil, rust, oxide scale, etc. Within 20 mm on both sides of the test piece to be welded until the metallic luster is obtained. This is test piece after grinding. 5. Preparation of welding materials. According to the material of the test piece, we choose E5015 electrode with better process performance, and prepare 2 kinds of diameters, 2.5 mm and 3.2 mm. It should be dried at 350 to 400 degrees Celsius before welding. Keep warm for 1 to 2 hours. Take it as you go. We begin to assemble the test piece. After inserting the pipe into the through hole of the bottom plate, adjust the nozzle to align with the bottom surface of the bottom plate and then start to fix it. The fixing point is not allowed to exceed 3 points, and the weld length of each point does not exceed 10 mm. After the assembly tack welding is completed, the center of the pipe and the through hole of the bottom plate should be concentric and have a good edge. This is schematic diagram of the point fixing position. Then measure the perpendicularity between the pipe and the bottom plate with a square ruler. The deviation of the adjustment should be less than 2 degrees. This is an assembled test piece. Hold the fixed specimen horizontally on the tooling table and adjust the height according to your own operating habits. When you are ready, you can start soldering the bottom layer. The welding of the bottom layer can be either arc extinguishing welding or continuous arc welding. Here we take arc extinguishing welding as an example to explain. Select the electrode with a diameter of 2.5 mm and adjust the welding current to 70 to 85 A. When welding, we divide the welding seam into two half circles on the left and right along the vertical center line of the tube sheet. The right half circle is in the counterclockwise direction, and the left half circle is in the clockwise direction. Weld from bottom to top, according to the personal habits. Weld first. Either the left side or the right side can be welded first. Note that the arc starting and arc ending parts should exceed 5 to 10 mm of the vertical certain line. We ignite the arc at the bottom welding position of the test piece, and the small zigzag swings 3 to 4 times to make the workpiece fully preheated and then extinguishing the arc. When the temperature of the molten pool drops and the corner is dark, the arc is quickly ignited. The electrode is sent to the angle of the root of the welding seam, and a small zigzag swing is made between the tube and the plate. After 1 to 2 round trips, the arc is extinguished. During the welding, 1/3 of the arc is pressed on the previous molten pool to form a weld, seam, and so on, until top flat welding position. Stop operation. At this time, we have completed half a week of operation. During welding, the electrode and the bottom plate form an angle of 45 to 50 degrees, so that the arc heat is evenly distributed on the tube side and the plate side, and the edges of the welds on both sides are well fused. The angle between the electrode and the welding direction needs to change with the welding position, and keep adjusting. Keep it around 60 to 70 degrees. This is a schematic diagram of the angle transformation of the electrode. When making joints, ignite the arc in front of the arc creator and swing it slightly. After filling the arc creator, press down the arc, push it to the root of the weld, and resume the previous welding steps. Repeat the previous operation process and finish the welding of the bottom layer after welding for another half cycle. This is a test piece after primer is completed. Finally, we carry out the welding of the cover layer. For the cover layer, we choose an electrode with a diameter of 3.2 mm and adjust the current to 90 to 111 A. The amplitude of the swing of the cover layer electrode should be slightly wider than that of the bottom layer. The angle of the welding rod, the method transporting the rod, and the bottom layer are basically the same. It should be noted that because the circumference of the tube side is short and the circumference of the plate side is longer, the welding distance on the plate side will be slightly larger than that on the tube side. When the cover layer is welded, the swing amplitude and spacing of the electrode should be more uniform and consistent, and the arc should be slightly depressed and paused at the edge of both sides of the welding seam to prevent undercut and make the welding seam more beautiful. After the cover is completed, clean up the welding snag and spatter on the surface of the test piece. This is test piece after welding. The key technical point of the horizontal fixed work position welding of the plug-in tube sheet is to achieve fast, accurate, and ruthless. First, the frequency of arc ignition and arc extinction should be fast, especially when using alkaline electrodes. Accuracy, the arc ignition position at the red-hot molten pool should be accurate. Ruthless, that is, The action of extinguishing the arc must be neat and tidy, especially when the arc extinguishing welding is extinguished. It must be simple and not drag arc. Tools and equipment must be sought after exercise. Turn off the power, clean up the site, make records. Visual inspection. The surface of the test piece must be cleaned, but there should be no traces of processing, grinding, or repairing, and then correct according to the scoring standard. Welds are not fused. Surface snag includes surface spurs, cracks, weld thickness, weld neck symmetry, undercut, verticality, mechanical damage or arc scratches, weld surface forming and other items. To carry out self-inspection and mutual inspection one by one check. That's all for today's content. Thank you.